Hey guys, welcome to the first ODEs type of tutorial. This is my first tutorial on ordinary differential equations. As you may or may not know, a differential equation is an equation that has a function as a solution. So it's like yeah, you've seen it before. Like if y prime equals 2t, then y is t squared. That's the this is a differential equation, and then this is the solution. Yeah. So let's so the first type of differential equations I want to show you have a certain characteristic, and what happened? I accidentally erased it. Okay, and so the first is like is a type where it does something like this. It's ay prime prime plus by prime plus cy equals 0. And there is a very nice formula. Assuming a, b, and c are all constants, there's a very nice formula to solve these types of differential equations. And let me show you what it is right now. Anytime you have this type, y will always equal to C1 of E R1T plus C2 ER2T. And this is it kind of goes something like this. Y would be e to the power of RT. Y prime would be RERT. And then y prime prime would equal r squared e to the power of RT. And then you get that in and you get like almost like a quadratic equation of some sort. So let's go through them. Let's solve them one by one. Okay, so y prime, so y is ERT. Y prime is RERT. And y prime prime is equal to r squared. ERT. So let's this would be like, here it would be e to the power of RT. R squared minus 6r plus 8 is 0. And okay, so this e to the power of RT is never 0. R squared minus 6r plus 8 is 0, so r is 2 and 4. Okay, so then that means our solution is C1 e to the power of 2t plus C2 e to the power of 4t. And you can verify this for yourself. Just plug in any value for C1 and C2 that you like, and this will be equal to 0. So here's the second one. Y prime prime minus 4y prime plus 4y equals 0. Okay, so you'd have the e to the power of RT, r squared minus 4r plus 4 equal to 0. And you realize that there's only one solution to this. R is equal to 2. So wait, so you think about this for a second. You would originally say that y is equal to C1 e to the power of 2t plus C2 e to the power of 2t. But this doesn't really make sense. It's not feasible. It's so it doesn't just equal to C1 e 2t? Not exactly. This part we did correctly, but you see that the correct answer will actually be C1 e to the power of 2t plus C2 t e to the power of 2t. So whenever time a root overlaps, you have to multiply one of them by t, essentially. And I did this. I want to add some initial conditions just for fun, so you give a definitive value for C1 and C2. C1, here, okay, so let's see, y of 0 equals 2, meaning that meaning that C1 is 2, y prime of t is equal to, that would be 2C1 E2t plus 2C2 plus 2C2 e to the power of 2t plus C2 e to the power of 2t. Sorry, I forgot to multiply this by t earlier. So C2 okay, yeah. And y prime of 0 is equal to 4. And that's 2C1. That's 0. And 2, 4. We deduce that C1 is equal to 2. So C2 is equal to 2. And that's it for part 2. Part 3. Okay, so y prime prime plus 9y is equal to 0. And e to the power of rt r squared plus 9 equals 0. And then you would realize something very confusing. R will equal plus or minus 3r, 3i. So then you go, wait a second, y is equal to c1 e to the power of 3it plus c2 e negative 3it. But then recall from Euler's formula in linear algebra that e to the power of I theta is cos theta plus I sine theta. And that's what we're going to be using here. So, and because like of the C1 and C2, the constants can be both positive or negative, you don't have to worry about one of the roots. Let's just ignore the negative 3it and just focus on the 3it. So y is equal to e to the 3it which is equal to cos 3t plus I sine of 3t. And there's a principle that actually says that the solution to the ODE can both have the positive, the real aspect, and the imaginary aspect. And this implies that y of t equals c1 cos 3t plus c2 sine 3t. So there you go. That's the first thing I wanted to teach you about ODEs. It's a pretty nice. So as usual, if you have any other questions or concerns regarding stuff from grade 10 math to ODEs, then you can just shoot me an email. And yeah, but in the meantime, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.